Hello and welcome back. In the previous video, we created this app, signal plot app. So now if you go to the command window and you type signal plot, you should see it, right? And you recall we could enter an amplitude, a frequency, a duration, and plot the signal. So let's add a little bit more functionality to this to explore some of the additional features that we have with the designer. So we go to the app designer. So let's launch it. App designer. Actually, let's pick the right app. It's the signal plot app. So in the previous video, we had created this graphical user interface and added this code to the event of the user clicking plot. So let's add a couple more things. Let's, for instance, let's add the ability to add noise and a DC value. So I'm going to lower this down. Lower this down a little bit. You can, incidentally, you can just Control-C and Control-V to duplicate a particular field that you already have them. Call this DC. And so I'm going to rename this as DC in the component browser. I can mention that if you go to the code view, it automatically gets renamed to whatever you do it. You change the name to, right? DC2. There you go. You can see it here. So that's going to enable us to add a DC value. And I'm going to make this a little bit bigger. And let's enable the possibility of adding noise. So I'm going to say this is going to be like the noise amplitude, with a slider. And what I'm going to do is just put it from 0 to 10, actually from 0 to 5 in increments of 5. I'm going to make it a little bit smaller, better, and that's for a signal. Make this a little bit smaller. I'm going to So this is our signal one. I'm going to add a label here. So label signal 1 or channel 1. And then we can add a signal 2, perhaps, but let's add this functionality first. So let me use this. I'm going to bold it right there. Okay, so let's add this functionality to the plot amplitude. For that, we go to the code view. Incidentally, anything that you have in the, I'm going to call this in the front panel, anything that you place, including labels, you're going to have a component browser there, because you can change anything that you have placed here in the front panel of your graphical user interface that you can see in the design view, whatever you have in the canvas. Programmatically, in the code view, you can change anything. So what I'm going to do here is I want to add the noise. And so let me create the noise signal as plus noise. I'm going to just call it noise. Actually, NS as being equal to the amplitude of the noise times. I'm going to create random numbers that are white, meaning they have all the frequencies in the spectrum, but Gaussianly distributed, rand and 1, and this is going to be the length of t. And so this power, this is the amplitude of the random numbers, and comes from this noise amplitude slider, right? So it's app that you can press tab to autocomplete, no amplitude slider. So there are two objects only in the front panel, right? The slider itself and the label. We refer to the slider. That, and now we are going to go to the properties. What are the properties that we have here? One of them is, of course, the value. So if I press V, autocomplete, it's going to say, okay, the value, right? So there we go. So this will enable us to, if we just click run, let's see how this is working. So let's enter an amplitude of 1, a frequency of 5, so 5 cycles. If we type this 1 second, explore it, and we got an error here. Let's see. Oh, yeah. This is NS, not N. Notice the debugger automatically tells you where you had the issue. In this case, right there, here is the line 33 undefined function or variable. So let's run it again. 1, 5 cycles in 1 second, no noise. Okay, so this is working, and this is what we had before. Actually, we have not added the DC value yet. Notice there's no, even if I type 10, nothing changes, but we did add functionality to the noise amplitude. So let's see if we add some noise. There we have. Now this is, for an amplitude of 1, this is quite a lot of noise. In fact, if I add 5, the signal to noise ratio will be that the noise is overpowering the signal, right? Now, I could increase the amplitude, and now I have, as I increase the amplitude here to 10, I have more signal power. And so even though we have this noise, we are able to still see the 5 cycles in 1 second. So it looks like this is working. Let's do 2 seconds. Yeah, this works. The noise, yep. As you can see, the slider is working. We set up the value, we plot it, and it works. So we still need to add the code for the DC. And then what I would like to add is another signal. And then perhaps we can do operations with those signals. So let's go with that. So to add the DC value, I can just perhaps enter here K for a constant, and this is my app that notice that we have DC autocomplete that value. So I pick the value from the user and I add it here. If I save it, incidentally, you can always go to your MATLAB code command window. This was signal plot app. There you go. And so now we're going to have a DC of 1, an amplitude of 5, a frequency of 5 Hz, a duration of 5 seconds. So we should see an amplitude of 5 cycles in per second, so 5 cycles, and a DC at 1. Explore it. And we're having an issue, so let's go ahead and check it. We enter a capital K here, it should be lowercase, as we defined it there. So let's go ahead and run it again. Okay, so as you can see now, we do have a DC value. Let's make it more apparent by adding a DC value at 10. There you go. Right. So this is now working. And let's add some noise. This is working. Okay. Let's go ahead and add another channel with the signal too. So to do that, you can go to design view, and perhaps we can just go ahead and copy all this as is, all of it, Command C or Control C, depending on whether you're working on a Mac or a PC, and you can just copy this over. You can copy the slide, amplitude, but not the slide. Let me just delete this. So I'm going to call this signal 2. And let's enter the code so that we can plot both of them. Notice, incidentally, all this has been added, right? And so all we need to do is here define two signals now, right? So we have an x1, I'm going to call this one x1, and I'm going to create an x, well, actually, let me do the code differently. I'm going to plot at the end, and so now I'm going to copy this and create my second signal. Incidentally, this shows a concept in programming that you should keep in mind, and it is the following. If you're doing a small function or a small app, something like this, perhaps you can just go ahead and code right away. But as the apps become larger and with more functionality, it is not a good idea to start coding without doing design, right? I mean, I will have written the initial code differently if I intended that this was going to be an app where I was going to have two channels with two signals, with noise, with the ability to perhaps to add operations in those signals, like if I wanted to say the results of adding, subtracting, amplitude modulation with a suppressed carrier, large carrier. In those cases, I can go ahead and incrementally adding functionality to that program as an add-on, but the program is not going to be as elegantly designed, it's not going to be as robust. So if you have a more significant project, certainly anything that you expect that is going to take you more than 1 day of coding, more than 8 hours of coding, before starting to write code, design. Think about what are all the features that you want, what are the design elements, what are the sub-functions that this is going to have, how are you going to divide the problem solved, and make sure that you, of course, have the solution algorithms implemented before starting to code. Otherwise, this is like evolution. It's not going to be as elegant of a solution. So what I'm going to do here is saying, okay, I'm going to call this x1, I'm going to call this x2. Fine, they have potentially different frequencies, etc. So perhaps I could call this is K1, A1, F1, T1, N1, FS1, T1, and this depends on this here. So as you can see, this is let me say T1, noise 1, and so all this is K1, amplitude for the first signal, first frequency, first time, and then noise, right? And so now this is the second signal, for which this is DC. Notice that this is DC, is this one here. And this is amplitude 2. That's what happens when you just copy it. Two. For instance, if then we want to do operation, we will want them to have the same length, and so we will not want that this is different from the first one, etc. So let's just go ahead and do something like this for now, quick and dirty. And then let's plot everything together. So we plot the first signal in blue, T2, X2 in red. Let's see if this works or if we get any bugs. DC1 amplitude, A5 frequency to duration 1. This is 0 amplitude 1 frequency 10 duration 1. Okay, TS was undefined. Let's see what is TS1 and TS2. Run it. N is undefined. Let's define N. This is, of course, N1, and this is N2. This is K1, K2, K2, right? Let's fix this, A2. So let's run it. Okay, so I'm going to do a DC of 1, amplitude of 2, frequency of 3, duration of 1, no noise, and here I'm going to do no DC, amplitude of 1, frequency of 10, duration of 1. There you go. So we have now a 10 Hz signal, 10 cycles in 1 second, and a 3 Hz signal. Let me add some noise to the lower frequency signal, the 5 Hz. So we see now some noise added. The other one is clean. Let's add some noise to the second signal. There you go. So it looks like all our functionality is working. And we could add additional functionality, right? We could say, well, I want to use this, for instance, to explore amplitude modulation, meaning multiply once times the other with our DC value to do a double sideband suppressed carrier amplitude modulation, perhaps, or with the DC value to explore double sideband large carrier or transmitter carrier amplitude modulation, or I could even do more operations, right? I could add here a selector that will enable me to do that. So I'll show you how we could go ahead and do something like that. Cool, for instance, add a list box here. We're actually going to take the label out. And in the list, I could define, okay, this is adding, add, subtract, multiply, double sideband suppress carrier, because perhaps we will do it without the DC, and multiply double sideband large carrier with a DC component. Yeah. And this is a selector that the user will be able to select, right? So I'm going to run it. Right now there's no code for it. And you will select one signal, another signal. Incidentally, because we were incrementally adding this code, the fact that the duration is different for both of them, so let's do here, for instance, 1, amplitude 4, frequency 3, duration 1 second, no, amplitude 1, frequency 10, duration 1 second. Both of them are controlling the duration. So what happens if I increase the duration in 2 and not 1? Well, what happened is that if we do 2 seconds, it will only do it for the signal 2, and in 1, you will only see it up to 1 second, for instance. We may want to, of course, design this better. Now, how will you add the code here? For this, you can do it just with a case statement, which there are 2 case statements that you have to control execution in MATLAB. There is the if, else if, else if, else is else, or there is also a switch statement for each one of the cases. In this case, probably given how finite this is, etc., this could be done. And by the way, you have here the selector, the selector with the values. This can be done with a switch statement easily. Okay, so what we will do is a case where then we operate on x1 and x2, adding and subtracting, etc. Now, to do that, we need to go back and change the code, because right now notice that this length, I mean the number of points that you have, is dependent on the sampling frequency, which is dependent on the maximum frequency. So the length of x1 and x2 is different, and therefore you could not do operations. This is what I was mentioning before, that it is much better to design based on what is the overall functionality that you want, because now we'll have to go back and recode this by saying, okay, actually, both of them have to have the same length, so probably we have to check which one has the highest frequency, do 50 times that frequency, and then put it in the switch statement. This is just to illustrate the concept that plan before starting to code if you want to have elegant, well-designed programs. So let me recap here. I'm not going to add the code there. We have seen how to use two-dimensional plots. We have seen the edit fields, numeric. You could also use text fields, and if you then need to convert them to numeric, you can do a text to numeric conversion. We have used labels. We have added a list box, although we have not added code for it. We have used sliders. All of them basically work the same, okay? So you have some that are common components, you have some containers if you want to add more panels and tab controls, and then you have some instrumentation knobs and things like that. Thank you.